In question 24a, we have two circuits, 1 and 2, and we're asked to find the ratio of the current in circuit 1 to the current in circuit 2. Well, the current is V over R, so the ratio is going to be V1 over R1 divided by V2 over R2, which we can rearrange as V1 R2 over V2 R1. The potential differences are the same, so we can cancel those. We're after resistance in circuit 2 divided by resistance in circuit 1. The resistance of circuit 1 is just R plus 2R, which is 3R. For circuit 2, we can say 1 over the resistance in circuit 2 is equal to 1 over R plus 1 over 2R, which is 2 plus 1 over 2R. Therefore resistance 2 is 2R over 3. Therefore, going back to this arrangement that we're wanting, we've got the I1 over I2 is equal to 2R over 3 divided by 3R, which is 2R over 3 times 3R. The R's cancel and we have 2 over 9, which comes out at 0.22 amps. 0.22, sorry, not amps. The units cancel. In part B, a student has two identical filament lamps and a variable power supply giving a current of 0.030 amps. They then double the EMF of the power supply, expecting the current to double, but it only rises to 0.04 amps. Where to use our knowledge of physics to explain the observations? Well, the current is 2/3 of expected. This is because the resistance of the lamps has gone up as the temperature has gone up due to the current. The resistance has gone up by 3/2 for the current to only go up by 2/3, or 1.5 times. In C part 1, we're to find the resistivity of the metal. Well, resistivity ρ is equal to resistance times area over length, which in this case the resistance is V over I times area over length. We can then put the values in. We have 1.8 volts times an area of 1.3 times 10 to the minus 7 square meters over a current of 0.026 amps times a length of 0.75 meters. This gives a value of 1.2 times 10 to the minus 5 ohm meters. In part 2, we're asked to explain one possible limitation of the experiment. Well, there's the resistance of the contacts, and this will give a higher resistance of the overall circuit, and so affect our values.